starting this course in just 2 or 3 minutes. I'm waiting for everyone to join this course. This live session. We'll wait for 7:05, then we will start. Course in just 2 or 3 minutes. I'm waiting for everyone to join this course. This live session. We'll wait for 7:05, then we will start. Okay, we'll start the session now. Good evening, everyone. I'm Rohit. I am a PMS scholar in IIT Bombay, and I will be teaching a teaching assistant for physics of renewable energy systems. This is a course on NPTEL, and this course is taken by Professor Amit Chandra. He's from Department of Physics, IIT Renewable. So, in this course, we will be talking about the renewable energy system, different renewable energy systems. What are the physics or science that goes behind the renewable energy systems? And what are the different aspects of it? In this course, we will also see that some of the experimental setups that are required for this renewable energy systems, and different systems like bioenergy, thermal energy, some other forms of renewable energy like solar energy, thermal storages, So we will look after that in this course. So once again, I again welcome you all to the live session. Let's start this course. Okay. The first question is, are you able to see my question? Okay. You don't have to speak. You can be muted and just write in the chat box. I can read your message in the chat box. Okay. So that's not a big issue. You can start. Okay. So solar radiation. Basically, in question one, we see that solar radiation is mostly reflected by. So the options are clouds, atmosphere, and surface. If we see solar radiation, actually what happens reflected. So this is the Earth's surface, and this is the sun. And this is the outer atmosphere as such. So solar rays comes like this in straight line, not like this, in straight line. Okay. So there are some particles, small particles, minute, tiny microparticles. What are these particles? These are aerosols, molecules of gases, dust particles. Then there are clouds. Okay. So when the rays hit by particles or these clouds, they get reflected back to the space or to the atmosphere. They get scattered actually, and only a certain amount of rays reach the Earth's surface. Earth's surface also has some reflectivity value, so it will also reflect in other directions. So this is the whole scenario. And if we see that this cloud reflect around 20% of the total sunlight which it receives. These particles actually reflect 4 to 6%, and Earth's surface actually reflect 30% of the particles. Okay. This is how the budget is defined for radiation. So when sun ray reaches the Earth, that is Earth. So what do you think? Which is the most reflected solar radiation reflected by? So you can see here mostly it is reflected by Earth's surface. Clouds 20%, atmosphere 4% or something more than 10%, and Earth 30%. So the correct answer is C. And if you see the radiation, so there is a term we will talk about later in the slides. I discuss this in detail. So L below Earth's surface, this is called 30%. This is the technical term which we use for the radiation, and this is mostly reflected by clouds. 20% is the data. Okay. So when we talk of scattering, there are two terms: Rayleigh scattering and Mie scattering. So Rayleigh scattering is scattering of the light when the particles are more than the size of the wavelength of light. Okay. So here the lambda light should be less than particle size. Okay. In Mie scattering, what happens? The particles should be very much small than the radiation, which is wavelength of the light. It should be less than the wavelength of light. For if you want the exact data, it should be 1/10 of the wavelength of light. So where do we get these particles? These particles are actually in the atmosphere itself, like small volume gas, trace particles, dust particles, so they are also reflected back. So that is Mie scattering. MIE, and the another one in which the particle size is more than the wavelength of light, that is Rayleigh scattering. So everyone is clear on Rayleigh and Mie scattering? Okay. So everyone clear? No questions? Okay, you want to know about the values of Rayleigh and Mice scattering. Okay, So if we see here, how much is the Rayleigh scattering or how much is the Mice scattering? So Mice scattering, if we see this diagram, we see that 4 to 6% is through the small minute particles and 20% is through the clouds. So this value can be Rayleigh scattering, okay, and this is the Mice scattering. Now you got it clear? Mice, and this is Rayleigh scattering. Okay. Any other doubts? Anyone wants to know any other type of scattering? There is also some other types of scattering like Raman scattering. So these are very scientific scattering. This is scattering what really discovered by an Indian physicist, P.V. Raman, and on whose name he got it Raman scattering. Also, this scattering is very much used in spectroscopy. This is a field of science where we study the scattered radiation to know about the content of any particle. So this is very much important. I would suggest that all people read about this scattering. So this is very good concept. You will learn so much about instruments now. Could we move to the next slide? Okay, then we move to the next slide. So everybody can see my slides? Okay, nice. The second question is solar radiation intensity falling on the surface of Earth is called. So what should be the solar radiation intensity which falls on the surface of Earth? Should be called. This is the question. So one option is insolation, another is isolation, irradiance, another. So what should be called? Let us now look at the word intensity. What does intensity signify? So this is Earth. This is atmosphere. When sun ray reaches the Earth, this value is known as irradiance. The amount of solar energy received at the Earth's surface. But it receives per square meter. Intensity is what? Divided by some specific units. We look for some specific areas. So that's how intensity is defined. So we look for per meter. What is the solar radiation received per meter square? Earth's surface is not uniform. We can get some different layer, we can get some different layer because of unknown surface of Earth. Some atmosphere is getting also. So we are more interested to know per meter how much radiation we can get. So that's where the term intensity comes. And this the radiation reaching the surface of Earth can be called insolation also and irradiance also. Both are almost same for layman terms. But if we want to see the difference between insolation and irradiance is basically represents the power, that is energy per unit time. We see per meter square per second meter square, joule per second meter square. Okay. So how much energy per meter square per second is received in irradiance. For insolation represents energy. How much solar energy is received at that particular space. And so for this question the correct answer is A and C both. And now the next question, follow-up question. How much is the average insolation value of India? Anyone? Can anyone say how much is the average insolation value of India? And a question related with this, for what value of insolation solar PV are designed? So solar PV are basically designed for 1000 watt per meter square. Or you can say 1 kilowatt per meter square. So if you go to market to buy a solar PV cell, so there are cells at 20% efficiency, 70% efficiency. So how do you know which value of radiation this efficiency stands for? So all the solar cells which are in the market, they cater to they are calculated to 1000 watt per meter square. Now you know the solar cell will give 20% efficiency only when the irradiation value is 1000 watt per meter square. And how much is the average insolation for India? So it is around 0.5 to 1.5 kilowatt per meter square. This is the value. 0.55 to 1.5 kilowatt per meter square. This value is how much insolation received from India. So this is a range. This is not exact value. Why it is a range? Because not all the parts of India receive particular solar irradiance. Like Ladakh receives some other value, Madhya Pradesh receives some other value, Tamil Nadu receives some other value, Kerala receives some other value. So on an average, we can say range is between 0.5 to 1.5 kilowatt per meter square. This is how much the radiation is received by India. And make sure the units. This is lower watt per square. This is watt per square. And lower watt per square. This is much more watt per square. So don't confuse by the unit. Don't confuse by the term isolation. Isolation is basically in someone you are ostracized from rest of the others. Like COVID isolation, we isolate someone so that it can recover. Now everybody can understand. Any questions regarding this? Okay, you want to know that for India, everything is calibrated from 1000 per square. If we go in some other country like this, we just calculate it for some other value. These values are actually selected based on the data which is available for India. Like how much solar energy is available for India based on the data, we put a standard so that we can compare the different solar cells. Like if some solar cell is giving 25% efficiency, market is claiming that company claim efficiency is 50%, and some solar cell is giving 20% or 21% efficiency. So how can we compare this? We cannot compare this. If this is we are at 1800. This is giving at 1000. So this is like comparing apple to orange. We cannot compare it. We have to make a standard 1000. At 1000, how much is the efficiency here? At 1000, how much is the efficiency here? That's how we compare the different solar cells. Got it? Now we move to the next slide. What is the value of L2 for the Earth's surface? So there is a technical term here, L2. What does L2 signify? What does this albedo mean? This albedo basically is a technical term for fraction of total solar energy reflected back to space. We have seen in the case of Earth, like some solar energy received here, they reflected back to space. Okay. So this is how it works. And this fraction of total solar energy reflected back is called albedo. This albedo value is different for different materials. Like on Earth, we see that there are mountains also, there are sea, there are rivers, there are forests. So everything will have different albedo value. And combining all these things, we get to a certain value that is 0.3. Earth reflects on an average 30% of the total solar energy left to space. So albedo for Earth is 1.3. And a follow-up question regarding this. Okay, students. We were at albedo value. Okay. For albedo of Earth's surface, we have discussed in the question number 1 that 30% of the light is reflected by the Earth's surface. So, what do you think? What should be the albedo of Earth's surface? So, it should be around 0.3, that is 30%. So the correct answer for this albedo is 0.3. And what do you think the albedo for snow will be? Anyone? Okay, let me write it down. Nearby 0.9, I can say. It's 0.8. So why do you think snow appears white? So albedo value of the snow has a very significant role why it is appearing white, because it is reflecting 80% of its incident radiation back to the atmosphere or space. So when you see 80% of light is reflected by something, so it makes out and we see a white light. Okay, that's why snow appears white to us. This is one of the main reasons for snow being white. Now the question 4, photovoltaic effect. So photovoltaic effect was actually effect that was very much important, and it was discovered in 1839. And this effect was the basic effect that goes into the manufacture of solar PV cells. When you see the photo, okay, slides are not changing. Is it changing now? Yeah. Okay. If slides are not changing, just inform me. So photovoltaic effects are very much different from photoelectric effect. Both are based on same principle, like it will have some electrons, take out electrons. So who discovered the photoelectric effect? Anyone? Albert Einstein. Correct. So what Albert Einstein observed, that if we see a surface and strike it with light, if it crosses the work function of the metal, then it will emit an electron. This is photoelectric effect. In photovoltaic effect, what happens? We use instead of metals, we use semiconductors, and there is a region here. This is p-type semiconductor. This is n-type semiconductor. This is this region, depletion region, where hole and electron pairs are generated. This is photovoltaic effect. That is how photovoltaic effect is different from photoelectric effect. So photovoltaic effect was basically discovered by Edmund Becquerel in 1839. So the correct answer is 1839 C. And actually, after discovery of this photovoltaic effect, it took significantly 5 decades to build first true solar cell. This I could kept in mind. The first true solar cell was built after 5 or 6 decades of this in 1894. I just put this information so that you also have knowledge of this. So first solar cell were actually, if you see the first generation solar cell, they have very poor efficiency, 1 or 2% something, even less than that. So we then shifted to some organic solar cell. It has some good efficiency, around 10 to 15%. These are second generation solar cells. The third generation solar cells are basically dye-sensitized solar cell, DSSC. And fourth generation solar cells are perovskite based solar cell. This is the new area where research is going on. Now the next question. Okay, slides are changing. Everybody can see the slides. Okay. The DSSC solar cell. See the fifth question. I just did, had a discussion on this dye-sensitized solar cell. So DSSC solar cell is classified in. So DSSC is basically third generation solar cell. Okay. This you have to remember. This generation of solar cells you have to remember. So DSSC is basically a third generation solar cell. First generation solar cell were based on semiconductors. Second generation solar cell were based on organic carbon or something. And the fourth generation solar cell are perovskite based solar cell. And this DSSC was invented in 1991 by Professor Michael Grezel. So these cells are also called Grezel solar cells. So if anyone asks what is Grezel cell, so you can simply say them. This is dye-sensitized solar cell, and these solar cells are having very good efficiency, around 15 to 25%. The efficiency varies for dye-sensitized solar cell. Now moving to the next question. Question 6. Question 6 is basically asking what is the average work function for the metal. So if you see, we have to first understand what is the work function. Work function is basically minimum amount of energy that is needed to make the electron escape the surface. It is a metal surface. Basically metal has electrons in the outer layer. So if it is a metal surface, the light or energy beam strikes the surface, and if it has crosses the minimum amount of energy that is needed to make the electron escape the surface, then we will see a photoelectric effect. That is what Albert Einstein discovered. So for metals, we see that this value is around 5 electron volt. So this is the correct answer. Answer B. So, can anyone say if we strike some non-metals with electron? Can non-metals give electron if we strike it with some energy beam? Anyone? Yeah, quite great. If we cross the work function of that, basically the minimum energy, then it will also give electron. Non-metal do give electron. So it is not that only metal gives electron. This is actually electrical unit of energy, electron volt. So work functions are basically represented in electron volt. If you see electricity is basically represented in kilowatt or kilowatt hours. Thermal energy in joules. If we see the work function values, when we go through literature or something, these are mostly represented in electron volts. Okay. Now the next question. The next question is, in PN junction solar cell, the holes are generated by solar radiation falling at option A P region, option B N region, C depletion region, and D all of the above. Basically, what happens in PN junction solar cell? Let me draw it for you. This is P-type semiconductor, this is N-type semiconductor, and this is the region which is called depletion region. No change in slides. Okay. I guess it's visible now. Okay, this is P-type semiconductor, this is N-type semiconductor, and this is the region which is called depletion region. In this region, the electron hole pairs are generated. When the light strikes this region, the electron hole pairs are generated, and these electron hole pairs are basically moved to a different layers, and these are basically very much importance in solar cell because they are main regions for conduction in solar cells. So the correct answer is the depletion region, in which the holes are generated. Now an important question: when we design a solar cell, there is a term, or when we study solar energy, there is a term called solar constant. So what is solar constant? We have to understand this specific concept, solar constant, very clearly. So this is the Earth's surface, this is the sun. You know the sun rays travels through in a straight line. When it reaches the atmosphere, again not visible. Okay, just let me. Okay, I think it's visible now. The response time is very less. Okay. So what happens? Let me explain it again. This is Earth. This is Sun. So the sun ray actually travels in a straight line, but when it reaches the Earth atmosphere, there are some particles here and there. I think that's visible. Let me call. So I think now the response time is great. Okay. So when the rays reaches the Earth atmosphere, there are some particles here and there, some clouds or some gases molecules. What happens? They deflect these sun rays back. So we don't actually get to know what is the exact amount of sun rays that is received by the Earth per meter square. So that's why we go to extraterritorial limits and measure the amount of sun rays received per meter square just outside the boundary of Earth atmosphere. Okay, this amount is almost constant. I am not saying it is not changing. It changes a bit, but almost for a time period. If we see a time period for this will vary like this. So this For a time period, this value is almost constant, and it is equal to 1367. The units are watt per meter square. So always remember this term. This will be very much used in formulas for solar irradiance calculation for a particular day in the month. So this is the 1367 watt per meter square is called the solar constant. So what is the solar constant? This is the average radiation that falls on Earth. I think this should be modified. That not falls on Earth, that is just outside the extraterrestrial limits, outside just the atmosphere. So this is the correct answer. Answer A. Not the distance between Earth and Sun, not the time available for sun rays in a day. Okay. So now some fun facts about solar constant. Let me tell you some fun facts. If you can see my slides. Now it's very good. Okay. So what do you think? Solar constant is really a constant? Anyone? No. Solar constant is not actually a true constant like Stephen Boltzmann constant or Planck's constant that have a very specific value 6.626 into 10 to the power minus 26 or something. But solar constant is not a constant value, it varies by 3% actually, plus minus 3%. That is because the Earth orbit around the Sun is elliptical. So the focus of Sun, the distance between Sun and Earth actually changes throughout the year. So this value is larger when the Earth is at perihelion. Perihelion is in the first week of January. When the Earth is the nearest to the Sun, when you say. The Earth is nearest to the Sun in the first week of January. And this is smaller when Earth is at aphelion. That occurs in first week of July. At this day, the Earth is farthest from the Sun. So that's how it varies plus minus 3%. So there is a question also here. Do you think solar cycles are basically cycles in the Sun that happens almost every 11 years when we have solar storms. Some activity gets intensified in the Sun surface, in the corona or something. So we have more of electromagnetic radiation waves. We see that in solar cycle our radios or televisions are somewhat fluctuating or something. Scientists say that solar cycle is occurring, we cannot get the data from Hubble telescope or something. So that's how the solar cycle occurs every 11 years. And do you think the solar cycle has any effect on solar constant? Anyone? Okay, so let me tell you, solar cycle has a very... Okay, should I repeat the question? Okay, solar cycle is basically the cycle in which sun activity, the activity on the surface of sun intensifies. It's basically a geographical concept where we teach in geography. In solar cycle, the activity like some magnetic field changes around the sun. The poles of the sun actually interchanges their position every 11 years. So we see intensified activity during this solar cycle after every 11 years, where more of the neutrinos or something are bombarded in the solar system. So that is called a solar cycle. Solar cycle has a time duration of 11 years. Okay. And do you think this solar cycle has any effect on solar constant? So let me tell you the answer itself. Solar cycle has a very minute effect on the, because Earth is very much situated far outside, 15 crores kilometers from the sun. So it has an effect on solar constant that is around 0.2% or something. That is data I have taken from literature, and I put this into the slide so that you can also know if anyone asks that solar cycle affects the solar constant. So you can say, yeah, it affects very slightly. That can be negligible also. So we will solve a numerical based on this solar irradiance, solar constant which we studied. So the numerical, you can see the numerical, the question. Okay. The question is calculate the irradiance on the 1st June and 31st December. We have to calculate the actual irradiance that is received on Earth on 1st of June and 31st of December. So I have also provided the formula for your calculation. I know is the irradiance on the specific day on which we are searching. ISC is the solar constant 1367. That's why I said solar constant value is very much important. When we have to remember this value. And this is 1 plus 0.034 into cos 2 pi into n by 365.25. N is here basically number of days that is passed in the year. We count the 1st January as day 1. So 1st January as n equal to 1, 31st January as n equal to 31, 28th Feb as n equal to 31 plus 28 similarly. And this pi is 180. This whole thing is degrees, so it has been multiplied by pi. Okay, so if you see the 1st June, so number of days, if you count how many days has been passed in the 1st June, so 35 days for January this year, 28 days for February, 35 days for March, 30 days for April, 31 days for May, and on 1st June 1 day. So total 152 days should be passed for 1st June. So n value is 152. We put the values here and just calculate. This data is 1326.82 watt per meter square. Okay. Now you all take some pen and paper and you calculate for 31st December. What should be the value for 31st December? I give you 2 minutes, then we will meet and I will ask the actual value that we get on 31st December. Okay? Sure. Okay, the question is basically we have to calculate the value of irradiance. Irradiance, you know, total solar energy that is received per meter square of Earth. Okay, so we have calculated this value for 1st June. We need to calculate this value for 31st December. So simple, you apply this formula and calculate the irradiance value on 31st December. This is the question. No, no, no. 3067 is wrong. It should be more than that. Calculate it again. I think you have missed something somewhere. Quite correct. 1413 is the correct answer. Okay. So anybody who hasn't get it, let me solve for you. So for 31st December, what should be the value of n? Anybody? Anyone? 365. We just don't have to count days. We know we have 365 days in a year. This is not a leap year, so it should be n equal to 365 on 31st December. Okay? The ISC value, that is solar constant, is 1367. We got the n value here, we got the ISC value here. Just put the data, and this is 1367 into, when we put all the data in, then here the ISC value here, we get 1367 into 1.033. So that is equal to 1413. The unit is watt per meter square. So anybody who didn't get this? Anyone? I think everybody, everyone has got this. This is a simple calculation where we just put the values of n and ISC and we get the irradiance at that specific day. So that's why the value of solar constant is very much necessary to know. And using this formula, you can note down this formula also. I will put the slides, I will share the slides with you guys. Also, the video is getting recorded. So that was the main issue, the video recording that was getting stuck today. So video is getting recorded, it will be shared on YouTube also, so that you guys can refer again and again and go through this. If there are any questions, you can ask me directly in the discussion forum and on the NPTEL. I will answer. Or you can mail me also. I will give you my email. So any questions, any queries you can ask. So you know how the irradiance value are calculated for these 2 dates or any day. You can calculate for different days and check whether we get the value which are correct. So one interesting thing which I want to tell you here regarding the irradiance value. So let me tell you one interesting graph here that may be very much necessary. So if we plot it for different days, the irradiance value, the graph goes like this, something like this. Okay. This is the value on 31st. Sorry, this is the value on 1 Jan and this is again 31st. You know this value? This is 1430. Similarly, we can using this graph, we can know the value of solar radiance on any day of the year. So you see a cyclic graph here. This increases, this decreases, reaches a value, then again increases. This is how it works. Okay. So this lecture is concluded for today. We discussed around 9 questions, including one numerical and some basic concepts of solar energy that will help you in understanding the whole physics of renewable systems very clearly. So if there are any doubts or any queries, you can always find me at this email ID. You can note down this email ID, you can post your questions. Or you can simply ask them on discussion forum. I will go and answer each and specific question related to my slides or any question that you have regarding the course. You can always ask. The queries are always available from my side. Okay. So I find this session very useful. I think all of you guys enjoyed this session. You learned some good concepts. Or if there are any suggestions for me, you can also provide me, like you should design your course or slides like this. So I will, from the next class that is on Saturday 7 to 8, I will design my slides according to that only. Okay. So we can conclude this session. Anybody has questions? Yes, you are welcome. What can I? Renewable energy in future. So basically, when you talk about renewable energy, everybody is saying very good things about renewable energy, and renewable energy is good. But one thing after the course progresses, you will read about a concept called capacity factor. That capacity factor is very much important when we design a system to cater the loads of the people or houses. Renewable energy is intermittent in nature. Sun always doesn't shine, wind always doesn't blow. This is the main concept. So you have to have some backup system like nuclear energy, which are less polluting than thermal power plants, to back up these energy systems, renewable energy system. Or we can have some thermal storage system where we produce this energy, we can store this energy and release them when there is no sun or when there is no wind. So we have some battery banks also, big battery banks where we store the power. So renewable energy has a very good future going on towards the policy. Government of India is also pushing it for net zero emission. The world is going renewable, we also go renewable. Okay, I hope this answers your query. Latest renewable energy. Latest renewable energy in the market. You want latest data about renewable energy or latest renewable energy in the market? Latest renewable energy, there is nothing called latest renewable energy in the market. If you see the latest are this perovskite-based solar cells. These are latest. These are getting developed, so these are latest. Or you can say some bioenergy are also catching up. Like we have some gasifier-based thermal power plants. So these are on pilot scale. These are getting catched up. You can also study them in bioenergy. When bioenergy will come in this course, you will study about pyrolysis, gasifier. So these are also renewable because biomass is a renewable source. Okay. So this kind of related wind is also related, tidal, geothermal. A long list is there for renewable. Any more queries? No, it's not like that. Only physics graduate can work in renewable energy sector. Renewable energy sector is very large. It is growing day by day. So if you want to know the data, the renewable energy is growing by CAG of 17.5%, compounded annual growth rate of 17.5%. So every year it is growing by 70.5%. So lots of scope is there. There are some policy formulation also, some monitoring also. So not only physics graduate can work, everyone can work on it. Economics graduate or any science graduate, even people who can frame policy also. There are a lot of company, audit company like Deloitte, Ernst and Young, they are going into policy. They are suggesting policy change to government. So a lot of people can work. Everybody, you just have to be skilled enough to work there. This is the main thing. Okay. What is the scope of renewable energy after MSc in electronics? See, electronics are, if you see the electronics, I just know about the engineering, electronics engineering or something. If I have anything others in mind, that will also be related to it. See, electronics are basically goes into every system. Like if you see the renewable energy, I simply narrow down to solar cells. So solar cells are trackers, okay? Also solar cells are MPTEL, multi-power point tracking system. These are tracking mechanism based on a power source which it can generate, and it actually is similar to the tracker, 2D or 3D tracker that orients the solar cell towards the sun so that maximum power can be absorbed. Maximum irradiance falls on the surface of solar cell. So electronics have basically, if you know how to design, if you know the exact components, you can club with other 2-3 people or 2-3 people. Why? You can club with many other people. You can gain the experience. Like there are very MSME, skill development institute. They train people on this. Some central institute of hand tools or something type, MSME based. So they train people. You can even start with a company also. If you are from electronics background, electronics people have the you say more opportunity in this field, I will say. One more query, yes. See, there are a lot of softwares, depends on what you want to do. So basically the designing thing, when we design the solar cell, it happens on PVCs. More generally, we use PVCs for designing the solar cell. There are other software also like ANSYS also used in designing. Console is there, console multi-physics is there. You can say Homer is also there for integration of this renewable with grid. See, renewable produces electricity, that electricity goes into grid. But if you cannot feed electricity directly to the grid, you have to check whether it is compatible with the grid or not. So Homer checks it for it. Homer is there. Any more software I don't remember design that can be used or not. But it doesn't only cater down to the software requirement. It caters how you know the system. Okay, that can be acquired when you get training on the system itself. You will know which software are required for this. So training is more important. If you could work in some company, some smaller startups, there are a lot of startups in the renewable sector. You can work in some startup, get some in-hand experience. Then you can move up towards some big companies. AutoCAD is software used for drafting basically. So AutoCAD, I don't think AutoCAD is used in designing, because designing basically a 3D thing, and we have lots of simulation there. SolidWorks can be used. SolidWorks are preferable when you design something. AutoCAD is basically for drafting and mostly used when we have to prepare drawings, plan view or elevation view or something. And one more thing I want to add, AutoCAD drafters are very much required in companies. AutoCAD is like every company who works on ground need AutoCAD drafters, and they are paid very good. So you can, if you are an AutoCAD drafter, you have a mastery in that. Make it pasted on your resume that I know AutoCAD, or if you can add it with some certification, that will help, certainly help you in getting a job. Mm-hmm. Uh, this question is very fantastic question. I think if you are thinking on this line, I must say I admire you. Lightning, actually, when you see lightning, there is a concept of supercapacitors. I don't know whether we have this in the course, or you can search it on internet. The Helmert double layer based supercapacitors that are similarly based on lightning type of thing. We provide a charge, it stores the charge, and the modern electric vehicle chargers are actually based on supercapacitors. You just have to provide a charge for very less time, it stores the charge and charge the vehicle throughout the journey. So yeah, lighting has a very good amount of energy. I think lightnings are some 2 crore volts. So if we can harness this lightning and store that energy in some battery or something form, then it can solve a lot of our problems. Maybe one day you can work on it and design with some system, come to me like, yes sir, I built it, this system based on lightning. It is kind of 100% renewable. Anything which is not exhausted or it can be replenished over time is renewable, because lightning is happening every day, every time. When you have clouds, rainy clouds, we see lightning. So yeah, it is renewable. Huh. Yes. Hmm. So it can be said that it is intermittent in nature. Similarly, for monsoon season, we can say we don't have sun, but we have solar cells now. Because scientists, actually engineers and scientists work on it and figured it out. Even if we have no suns, we can operate this system. So just you have to figure it out how we can store the lightning, and we can run the system throughout the month without the next lightning it will recharge again. Okay. Mm-hmm. Okay. So when first main thing is that we know everything, we study everything, but we don't know how to build solar cells. And with very what I should say, I could not get the word. It's basically a bad for India, bad scenario I can say, that India doesn't have any manufacturing plants for solar cells. We import our solar cells from China. So don't you see any opportunity, like we import our cells from China? If we can manufacture it here only, you can start a small business. You can tap the customers within your city. Okay. So if you can learn the intricacies of designing, you can have a design team, you can have a material team. It doesn't see, Steve Jobs doesn't know how to make iPhone, but what he knows that how to assemble a team that can make him an iPhone that will be a hit globally. So don't think like I don't know, so I cannot start a company. Assemble people who know. Invest some, get investor. There are a lot of investors that are ready to invest his money into your concept. If that concept inspires some future action, they know that my money will grow. So they invest money. There are a lot of investors. So you can always start a company. Think along this line. You get to know the system, how you can sell this system to the people in the city, to people in your state. So that's how it works actually. Okay. Any further queries? Any question you can ask. I am taking all type of questions. Seems like everybody has asked his question and the arsenal is finished now. But it was very nice interacting with you guys. I like the passion in you guys to know about renewables. So it's very good. First, to understand the basic science inside the renewable. That's how this course is designed. It tells you about the science that goes into renewable. You got to know which the renewables are there. There are bioenergy, there are wind energy, tidal, ocean, thermal. So you know, then you decide your perfect area. I want to work in this area only. I want to work on those systems which are based on thermal. Then you put your effort on it. If you want to work in the company, such which type of people they are taking. Are they taking experienced people? Are they taking people who know softwares, who know AutoCAD? Then you get to learn those skills. Certainly you apply, you will get that job. There are dearth of jobs in this field, and people are actually seeking, the employers are actually seeking participants who have the better skills. Okay, so I think we can conclude this session here. It was very nice interacting with you people, and I find your questions very interesting. And if there are any doubts, you can always write it to me on that email. So we will meet on next Saturday with some week 2 question assignments and some basic concepts also. Okay, see you guys. Welcome.